Alright, so now we're going to try to finish up hyperbolas in this video. I don't know how it's going to go, but we're going to try. So, once we left the last video, our center was at -1, 2, which is over here. And our vertices are going to be distance A, so that's 2, square root of 4. And that's because the y is first, it's going to be parallel to the y-axis. So if I go up 2 and down 2 from there, I end up there and up there. And those are vertices. So my vertices end up being at -1, 0 and -1, 4. My foci, well, let's find it. So I get a squared plus b squared equals c squared. I get the square root of 5 for c. So my foci are going to be the square root of 5 from my center, which is going to give me -1, 2 plus or minus the square root of 5. So if I go in here and draw that, I'm going to be about there and about there. And let's find our transverse axis is going to be a length of 4. Our conjugate axis is going to be a length of 2. And my eccentricity is going to be square root of 5 over 2. My asymptotes in this case are going to be, well, because we are not on the origin anymore, we're going to use, oh dear, so let's go with y minus 2 equals, we're going to use the a over the b, x minus h, and so I get y minus 2 equals 2x plus 2, and well, of course, plus or minus in there, and so I get y equals plus or minus 2x. And if I'm using the minus, of course, well, don't want to use the plus or minus there. Don't use the plus or minus there. So if I use, I'm going to have y equals 2x for the 1 plus 4. I distribute the plus because then 2 times and then 2 times. And then if I'm doing the -2, I distribute, and I'm going to get y equals -2x plus, so that's going to be -2x minus 4 minus 2. Looks as if that's what it's going to go like. Oh, that should be 0. Because it's going to go slope down 2 over 1, so it's going to look like that. Yeah. Alright. Let's do the next one. Again, this one we're going to have you complete the square on each of them. Pause the video while you do it and see if you get the same thing that I get. Alright, so when I completed the square, I ended up with x plus 7/2 squared minus y plus 1/2 squared equals 0. Normally we want these to equal 1, so this is called the degenerate case. And you can certainly look in your book about the degenerate hyperbola. And they have an example in there. And to get the equations that are associated with this, we're going to do a little bit of factoring here. If I call this A and I call this B, I get the a squared minus b squared thing. So I'm going to use the difference of squares, but I'm not going to do the substitution. I'm just going to say, hey, this is x plus 7/2 x plus 7/2. And then one's going to be plus, one's going to be minus, and then I'm going to say y plus 1/2, y plus 1/2 equals 0, because it's a quadratic difference of squares. And do a little bit of math here. I know that I'm going to have x plus y, and this will be equal to 0, so I'm going to end up with a -4. And on this one, I'm going to distribute x minus y. That'll be a negative. And then I move it to the other side. I'll end up with a -3. And one more step here to get it in a nice format that you're used to seeing. Y equals x plus 3. So those are the degenerate case, where we just get two lines that cross. Kind of a neat outcome, called the degenerate case. Alright, so we're going to determine the equation of a parabola that have foci there and a vertice there. Let's just graph the information given. If I have a foci at 0, 5, and a foci down there of -5, and one of the vertices at there, and another one there, that tells me that A has to be equal to 3 and C has to be equal to 5, and I know that A squared plus B squared equals C squared when it comes to hyperbola. My center, of course, is at 0, halfway between the foci or the vertice, and if I plug in, I get 9 plus B squared equals 25, so my B squared must be equal to 16. With that, I have enough information to make my equation. We know I'm going to write the y squared first because my focal axis or transverse axis is parallel to the y-axis. And so I'm going to put that one first. We know the distance to the vertices are 3, so a squared is 9, b squared is 16. Simple enough. Let's take a look at this one. Determine the equation of a hyperbola with length of transverse axis C, or 6. That means my A has to be equal to 3. The length of the conjugate axis is 2, which makes my B equal to 1. And I have foci are on the line, x equals -1. That'll make it the focal axis. And the center is there. So let's start with trying to get an idea of what this looks like. Because I know if it's more of a vertical opening one, then the y comes first. If it's a horizontal opening, the x comes first. So I kind of have to get a handle on what it looks like before I write the equation. I know that my center is right there. And I know that my foci are going through the line x equal -1. So I know that my conjugate axis is right there. So I know that my y has to come first. So I'm going to write my part of my equation. I'm going to write that y minus 3 squared minus x plus 1 squared equals 1. And then I have to put the A and the B in there. Our A is the distance to our vertices, and they say that that's going to be there. So I'm going to say 9 there because our A was 3. And our conjugate axis would be a 1 there. Simple enough. And then, let's see what's going on here. Looks like we're trying to find the equation of a line that is tangent to our parabola. Let's see. Move some of that out of the way. Oh, all right. For our point x1, y1 on a hyperbola, the line tangent to the hyperbola P, if the branch opens horizontally, these lines are not parallel to the asymptote. So tangent line and asymptote are totally different things, so let's just plug in what we know. we know, what do we know? Well, I think this is more of a just saying the formula than doing it. I think on my notes I ended up saying, oh, you know this, we have a point up here, and I used that, but I don't think this is what it's talking about. This is just a general form, kind of like the general form that we did on the ellipse. So I think that is all for this week. I think I ended up with 6 videos. I'm going to try to get them attached and get them out to you tonight. Good luck watching them, and let me know tomorrow when we visit what you think of them, what I could do better. It's my first time doing this, so let me know. Thank you.